Okay, we are going to look at chapter 4.2 now, which 4.2 is on trigonometric functions. And so these are our friends sine, cosine, and tangent. And so we're going to start working on some trigonometry, and we're going to use these a lot to do a lot of stuff. If you're going to be a computer science major, a math major, physics major, going to med school, it's really important you know these, because these trigonometric functions you're going to see on more of your standardized tests, like your MCAT or your LSAT if you want to go to law school or something like that. It's really important to have a solid foundation on trigonometry, on trigonometric functions. So we're going to really hit this hard and make sure everybody has a great understanding of it. So first we start with, first of all, some definitions. You'll see something that says an acute angle. An acute angle is an angle where theta, this is the Greek letter theta, is less than 90 degrees. I guess less than or equal. No, I think it's less than. So an acute angle is less than 90 degrees. An obtuse angle like this is an angle that's greater than 90 degrees. So we'll be exposed to both, but we'll usually be using acute angles with our trigonometric functions. And so there you go. Now, trigonometry is usually done within right triangles. And here we got our Greek letter theta. Here's our right angle. That's the symbol for a right angle. And opposite the right angle is the hypotenuse. That doesn't look like the right way to spell hypotenuse. Well, whatever. I'm going to leave it. So I'm going to write it hypotenuse and cross that out so you won't know that I misspelled it. How's that? And then this side that's opposite the angle is referred to the opposite side. Surprise. And this side that's right next to the angle is referred to as the adjacent side. Now, if you get these wrong, opposite and adjacent, you're going to get all your problems wrong. So you have to make sure you get this correct. This is very important. Okay? Now, we have, I know you've all heard it, SOHCAHTOA, right? This is how everybody learns the sines and cosines and tangent rules. And the rule is, if I want to relate this opposite side to the hypotenuse, I can use the sine function. And sine function gives me opposite over hypotenuse. And this is a way to use angles to find sides. And that's what the sine function does. It operates on this angle to find the lengths of the sides. For cosine, well, that's adjacent over hypotenuse. And tangent up here is opposite over adjacent. So these are our three basic rules for our trigonometric function. We have another set. Wait, let me make this rectangle a little fancier. Let me get rid of that too. There we go. Draw my line a little tighter. Oops, get rid of that. Okay, now we have another set of rules, and that is cosecant, theta is 1 over sine theta, which if you're 1 over sine, you end up flipping this over. It is hypotenuse over opposite. And 1 over cosine theta is secant theta, which is hypotenuse over adjacent. And I guess we need a divider. And cotangent theta is 1 over tangent theta, which is this gets flipped over, adjacent over opposite. So these are another 3 set of equations that makes up our complete 6 trigonometric functions. Now, I don't know why sine theta is cosecant theta. Why isn't it secant theta? That doesn't make any sense to me at all. I've never understood that. Cosine theta is not cosecant theta, it's secant theta. So you have to think these are the opposite from what you would normally do. When you do cosecant and secant, it's the opposite from what you would think makes logical sense. Okay, I've never heard why they were described this way. No, stop that. Oh, well. All I know is that's the way it is. And so you just have to remember that that's how it is, okay? So you'll be given a problem where you're told sine theta equals 4/5. Find the 6 trigonometric functions. Students hate this problem, and it is the easiest of the easies, okay? And we'll do that one here. But first, if I got my right triangle, 30 degrees, and this is 3, and I want to know what the hypotenuse is. How do I do that? Well, I look and see, is this the opposite or adjacent side? That's the opposite side. And whenever I do a test or a quiz, I always have this staring at me. I write it at the top of the page. So opposite and hypotenuse, that's the sine function. So sine 30 equals opposite over hypotenuse. So if I can convert this to a number, well, then I can just plug it in and solve for hypotenuse. Now you need to be careful because your calculator can be set in degrees or radians, and you need to know how to look it up and see which one it is. Very important. And there's a test. I remember of all the sines and cosines, I know that sine 30 equals 0.5. That's the only one I remember. And when I have my calculator, I turn it on. If I'm doing some sines and cosine stuff, I do sine of 30 and I hit enter and see what it spits out. Oh, mine just spit out 0.5, you see? So if it spits out 0.5, I know that I'm in degrees. I gotta change glasses. Hey, there's pi, look at that. Okay, so mode, I'm gonna go down and hit radians. And how do I get out? Maybe there, quit. Oh, look at that. So now I do sine of 30. I did sine of 30 and I got negative 0.988 because this was 30 radians because I'm set to radians. The calculator doesn't know which one you mean. All it knows is how it's set on the calculator. So you need to make sure you set your calculator with the right units. I'm going to go back to radians. Oops, mode. And go down to degrees and hit enter. And then quit. Oh, wait, quit. There we go. Okay. That's how you do it. Is you got to make sure you're in degrees or radians whenever you calculate something. A lot of people make this mistake. Okay, so over here, sine 30, 0.5 equals 3 over hypotenuse. I'll multiply both sides by hypotenuse. These will cancel, and we'll get 0.5 hype equals 3. Divide. Hype equals 3 over 0.5, which equals 6. So the length of this side in the triangle is 6. Okay. Now, how do I find x, the adjacent side? Well, now there's 3 ways I can do it. Once you know 2 things, there's a lot of ways to find the third. I could do cosine theta, because that's adjacent, equals adjacent over hypotenuse. I could do tangent theta, because tangent theta is opposite over adjacent. I'm reading right off of here. Opposite over adjacent. Not a good choice because x is in the denominator. Or this is a right triangle. So I could do a squared plus b squared equals c squared. 3 squared plus x squared equals 6 squared. I could use the Pythagorean theorem to find this third side. So we have a lot of choices. I'm going to say since x is in the numerator here, this is the easiest choice. So I'll do cosine of 30 equals x over 6. Cosine of 30 comes out to be 0.866 equals x over 6. So 6 times 0.866 equals x. What's that? Or you could do 6 times cosine 30 all in one line. There you go. 5.196. I guess I'd call that 5.2. Good enough. So this is how we're going to use these trigonometric functions to find the missing pieces in a right triangle. Okay. Now there's special triangles. They're not special because their mom told them, you're special. It's not that reason. We have two special triangles. We have a 45, 45. That's not a very good 5. Right triangle. And there's a 30, 60, 90 right triangle. Okay. Now here's the thing with triangles. No matter how you make it, if you do a weird, goofy triangle like this, let's say, there we go. Notice this is the shortest side, and then this one's a little longer, and then this is the longest. The shortest side is always opposite the smallest angle. Here's the smallest angle. And then this is the next biggest angle, and it's opposite the next biggest side. The biggest angle is always open to the biggest side. That's how it always is in triangles. So it's the same here. Little angle, little side. Big angle, big side. Now there's lots of ways to remember these. I remember them this way. I don't know how the book does it, and I don't care. Square root of 1 over 2, square root of 2 over 2, and square root of 3 over 2. I remember these three numbers, and then I use ratios to figure out the rest. So why square root of 1 over 2, you ask? So I can remember the pattern here. And over here, the smallest angle I said is opposite the smallest side. Which one of these three is the smallest side? Yeah, obviously it's that one. That's why I have the square root, so you can easily tell. So square root of 1 over 2, that's just 1/2, right? And then the biggest side is square root of 3 over 2. Well, this is 45, that's 60, that's the biggest angle. So this must be radical 3 over 2. And that leaves these to be square root of 2 over 2, and this one square root of 2 over 2. In a 45-45 right triangle, the sides of the triangle are equal because the angles are equal. And all of them have a hypotenuse of 1. This is the way I remember the special triangles. And now if somebody tells me, give me an exact solution, I don't know how to spell today, to sine of 60. Exact means you can't use a calculator because a calculator is going to have to round, because for both of these two, these are irrational numbers. When you do square root of 2 or square root of 3, it goes on forever. So you need an exact solution that means you use the special triangles. Okay, so an exact solution to this, sine of 60, 60's here. Sine is opposite over hypotenuse. Which side is the opposite side to 60? Not to here, to 60. And the opposite side is that. So sine 60 equals opposite over what? Hypotenuse, which is right there. Oh, so that's just radical 3 over 2. That's easy. What's the exact solution to sine 45? Well, it's over here. Sine 45, it doesn't matter which one we're talking about. It's going to be opposite over hypotenuse. So square root of 2 over 2 all over 1. So that's just square root of 2 over 2. So there you go. So I can use these to figure out what the exact solutions are. And now we may be asked, since we know, does that work? Oh, look at that. I didn't know I could do that. That is super awesome. Oh, new toy. Okay. If I have a triangle, that says is 2 radical 2, and these are 45 degrees. Now keep in mind, oh, let's not do that. Let's talk about similar triangles first. So I can have a triangle like this one, 45, 45, right triangle. Well, I could have another one that its sides, 45, 45, right triangle. Well, this could be a length 3 and this could be length 3, right? Triangles can be any size, but these two are similar, meaning their sides are in proportion to each other. They're proportionate. There's a constant ratio between all the sides if they're similar. So if they're similar, and I have something like, oops, I'm making pretty ugly 45, 45s, okay. So let me go back to my example. If I say this is 3 radical 2, and we know this one's 3 radical 2, what's the hypotenuse? Well, how much bigger is this than that? Right? So I could use a ratio. I'll use the ratio of, how would we do it? Square root of 2 over 2 over 1. This ratio to that is going to be equal this ratio over that. Equals 3 radical 2 over hypotenuse. Right? And so I could cross multiply. Square root of 2 over 2 times hypotenuse equals 3 radical 2. I could divide through by square root of 2. I'm going to get rid of these, right? If I do 1 over radical 2 and 1 over radical 2, they're going to cancel. So I'm left with 1/2 times the hypotenuse equals 3. Multiply both sides by 2. I'll get hypotenuse equals 6. So this must be equal to 6. So I use this pattern because this is easy for me to remember. And the reason it's easy for me to remember is it's easy for me to remember square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. You might have learned it different in high school. I don't care. You do it any way you want. I don't really care. This is how I'm going to do it because I can always remember this even when I'm stressed on a test. I'm still going to remember that. Okay? So there you go. That's my 2 cents on it. Okay. The other thing we certainly could have done here is we could have used the Pythagorean theorem. 3 radical 2 squared plus 3 radical 2 squared equals c squared. So 3 radical 2 will be 3 squared times square root of 2 squared. This will be 3 squared times square root of 2 squared. So that's 9 Square root of 2 squared is 2, so that's 18. So this one will be 18. 18 plus 18 is 36. So C would equal 6, which is what we got. So you could do it that way as well. You may not be as lucky because maybe all you're given is a 30, 60, 90 right triangle. And you're given 4 radical 3 here is that side. And you want an exact solution for the hypotenuse. So you'd have to do some dancing to do that. So I'd use ratios again. I could do this over that equals that over that. Let's do that. So if I wanted to find x here using these two triangles, I could compare those two and compare those two as long as they're corresponding parts. 4 radical 3 over radical 3 over 2 equals 4 x over 1. So I'm not going to deal with this fraction here. I'm going to cross multiply. 4 radical 3 is equals to square root of 3 over 2 times x. I'll multiply through by 2 to get rid of denominators. I found denominators give people a lot of heartburn, and so get rid of them as soon as you can. So I'll multiply both sides by 2. So the 2 will move to this side. 8 radical 3 is equal to x radical 3. Oh, look at that. What's x equal to? X equals to 8. I can divide through by square root of 3 to get rid of those on both sides. So x equals 8. Okay? I like to use ratios because ratios make sense to my old gray-haired covered head. So that's what I do. And when I use ratio, I can make all the problems seem the same, so I don't have to remember lots of equations. I remember patterns, and patterns are key in math. That's how you're going to be successful, is remembering patterns. Okay? So let's go to the dreaded 6 trigonometric functions. Okay? So a problem says sine theta equals 3 over 5. And it says, give me all the other trigonometric functions. State all 6 trigonometric functions. So I need to know sine theta equals, cosine theta equals, tangent theta equals, which is the 1 over sine? Is that secant? No, it's cosecant. And 1 over cosine is secant. Oops. And 1 over tangent is cotangent. Okay, that one at least makes sense. So I got to find all of these, and I know this one is 3/5. So first thing I'm going to do is draw a picture. Here's theta, and sine theta is opposite over hypotenuse because, oops, I wrote SOHCAHTOA right here. So sine is opposite over hypotenuse. So this has to be 3, and this has to be 5. Okay. Well, I'm going to solve for this side. 3 squared plus x squared equals 5 squared. Let's see, 9 plus x squared equals 25. Subtract 9, x squared equals 16, x equals 4. 3, 4, 5 right triangle. Special triangle. Not 30, 60, 90. No, these different angles. Okay, so now I know sine is opposite over hypotenuse. Cosine, I'm just going to use SOHCAHTOA here. Cosine is adjacent over hypotenuse, 4 over 5. And tangent is opposite over adjacent, 3 over 4. And I know cosecant is 1 over sine. Oh, look, I make my arm disappear. Look at it. It just flips. So this is 5 over 3. And secant, I'll make my arm disappear again. How did I do that? There it is. Ah, my hand. This will be flipped, so this will be 5 over 4. And cotangent is 1 over tangent. So that's 4 over 3. Boom. Not hard. Okay? That's the 6 trigonometric functions. Now, sometimes it's not so convenient, and you get a nice number of 4 here. Like, what if the triangle was 5, 7, and x? So 5 squared plus x squared equals 7 squared. So 25 plus x squared equals 49. Subtract 25, subtract 25. X squared equals, what would that be, 24. 24 is not a perfect square. X equals square root of 24. And we can't leave it as 24 because there's perfect squares in there. Because I could write this as 4 times 6. And 4 is a perfect square. So that's also square root of 4 times square root of 6. And square root of 4 is 2. So my x here is really 2 radical 6. So now, let me go through and we'll do this again. Equals. So sine theta, so this will be 2 radical 6. Sine theta, here's theta, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Opposite over adjacent. So we'll talk about that one in a minute. Cosecant is 1 over sine, so we flip it. Secant, it gets special colors. We're going to flip 1 over cosine. So 7 over 2 radical 6. And cotangent is 1 over tangent. It gets flipped. 2 radical 6 over 5. Now, why do I write these in blue, other than it's beautiful? It's because I have a square root in the bottom, and you are not allowed to have a square root in the bottom. So 5 over 2 radical 6. This will get marked wrong. You have to multiply by square root of 6 over square root of 6. And what happens when you do 2 times square root of 6? It'll become 6. So 6 times 2 is 12. So that's what we have to have in here. Okay, we have to have 5 radical 6 over 12. You have to have a rational denominator, and that's an irrational function if you leave a square root of 6 there. And so 7 over 2 radical 6, this one. So I'll multiply by square root of 6 over square root of 6 to get rid of the square root sign. So that'll become 7 square root of 6 over square root of 6 times square root of 6 is 6. 6 times 2 is 12. So this will be 7 square root of 6 over 12. Now we got the 6 trigonometric functions. Okay, that's about as bad as they get. Okay, now let's say, wait, let's see what else we got. That might be about all we have to cover. It is. Oh, no, 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 no. One more thing. Thought you were free. Ha! Don't think so. Let's say we got this. We got a right triangle and we got an angle theta. And this side is 60. And this side is 24. And we're asked, what is theta? I don't know how to do that. So, well, I can write an equation, and for this is the angle theta, this is the opposite sine, and this is the adjacent side. So that's opposite over adjacent is tangent. So tangent theta equals opposite over adjacent. And if we want to solve for the angle theta, if we're looking, oops, only two O's. Looking for the angle. Then we use the inverse tangent button. Or you might use arctan on your calculator. Oops. Or you might have tangent to the -1 on there. All of these things mean inverse tangent. An inverse tangent is the inverse function to tangent. And so, as you remember from what we did earlier, if I have a function and I operate on it by its inverse function, I get the argument from inside the function. So it's the same thing here. If I have tangent theta equals 60 over 24, one way to solve for theta is take the inverse tangent of both sides. The inverse tangent of tangent, these are inverse functions, it'll just give me theta. So I'm going to take the inverse tangent of 60 over 24. That means I'm going to hit inverse tan and then parentheses 60 over 24. Or you would have calculated this in decimal form and plug it in there. So let's do this and make sure we can all get the same answer. Uh-oh, I gotta see. So I gotta use the other glasses. Oh, there's pi right there. Look at that. Okay, so 60 over 24 is equal to 2.5. So I'm going to do on my TI-84 plus, I'm going to, where's inverse tangent? It's above tangent. So I'm going to hit second tangent, and then I'm going to put in 2.5. And I don't know if I'm in degrees or radians. So I don't know what that answer means. So I'm going to do a quick test. Sine of 30, I got 0.5. So if I get sine, if I get sine 30 equals 0.5, then that means I'm in degrees. Okay, so then my answer that I got when I did inverse tangent of 2.5, I got 68.2 degrees. That is not it. 68.2 degrees. So this is the angle theta right here. 68.2 degrees. Now, if I wanted to find the hypotenuse, I have a lot of choices. I could do sine theta, sine 6, don't lag, come on. Wait till it catches up, okay. Sine of 68.2 equals opposite over hypotenuse. And then I could solve for hypotenuse. Or I could do the Pythagorean theorem to find it, one or the other. Use inverse tangent, inverse sine, inverse cosine when you're looking for the angle and you know both sides already. Okay? Okay, so 4 and 11. Find this angle. Right angle. Go ahead and pause and do it. Okay, so first thing you did, of course, is wrote SOHCAHTOA. And for this angle, this is not the opposite side, that's the adjacent side and the hypotenuse. Adjacent, hypotenuse, so I'm going to use cosine theta equals adjacent over hypotenuse. I'm going to go to my calculator, whose buttons I can see. 4 divided by 11, boop. So cosine theta, when I did 4 divided by 11, I got 0.36363636 repeating, so 0.36. Now I'm going to do inverse cosine of 0.36. second cosine gives me the inverse cosine of 0.36. And I got theta equals 68.899. So 68 point, oh, well, what am I doing? 68.9 degrees. Okay, does that make sense? So you use the inverse button. For me, I hit the second and then I hit cosine because that's what it is on the TI-84 Plus. But if you have a regular calculator, it may not have second, it might have the inverse button. Or sometimes you will have arctan. Arc means inverse. I don't know where arc came from in the world of math. I bet a math historian does. But arctan is the same as inverse tan, is the same as tangent to the minus 1. This means inverse, just like when we were doing inverse function, f to the minus 1 meant inverse function, not 1 over f. Okay? I think that's all we got. All you got to do is go crank through the homework, be diligent about those, and you'll find that the patterns are easy to remember and you're able to follow through with this. Okay? So please come to office hours, ask for help. We're going to do some more example problems there. It wouldn't be surprising if some of the example problems ended up on a quiz or a test. So it might be beneficial for you to be there. And that's it for now. Have a good day. Bye.